Hello everyone and welcome to the lecture on Amazon Route 53. So what is Amazon Route 53? 1. A highly available and scalable cloud domain name system DNS web service. Route 53 connects user requests to infrastructure running in AWS such as Amazon EC2 instances and can also route users to infrastructure outside of AWS. 2. Designed to give developers and businesses an extremely reliable and cost-effective way to route end users to internet applications. By leveraging AWS global network infrastructure, Route 53 provides a cost-effective, scalable way to manage application traffic. 3. Supports DNS management, domain registration, and health checking. Route 53 provides a comprehensive service that includes managing DNS records, registering new domains, and conducting health checks on your resources to ensure smooth traffic management. 4th, ensures low query latency and high availability for your applications. With its global network of DNS servers, Route 53 is designed to automatically answer queries from the nearest server, ensuring low latency and high availability for your applications. Number 5. Offers advanced routing options like geolocation, latency-based routing, and weighted round robin. These features allow you to route traffic based on geographic location of your users, application latency, and distribute traffic across multiple resources respectively, enhancing the user experience and application performance. Okay, this is a high-level overview of Route 53. So we have end users and their queries, for example google.com or any website at aws.com or any website that you twitter.com, facebook.com. First it will go to DNS resolver, which will resolve the domain name, the top level domain queries on behalf of end users. Then anything that is hosted on Amazon Route 53 gets routed to Amazon Route 53 authoritative DNS service. So it returns IP addresses for DNS records queried by the DNS resolver. So this is the top level DNS resolver, which resolves domain name queries on behalf of end users. And this resolver could be public DNS resolvers. For example, Google has very famous 8.8.8.8 DNS server, and Cloudflare similarly has this particular DNS server. Or it could be a DNS resolver owned by any ISP, internet service provider, organization, or individual. And then it goes to if your website is hosted on AWS, then this will kick in, and it has its own features like health checks, CloudWatch for making sure your application is up and running, and there's endpoint instances. It could be EC2, it could be exposed via load balancer, and you can interact using management console or the Route 53 SDK or the API. Okay, how domain registration works. First, choose and confirm the availability of a domain name. Start by selecting a domain name and ensuring it is not already registered by someone else. If your desired name is taken, you might need to consider alternative names or top level domains, TLDs. For example, it's like .com, .net, .org. They are called as top level domains. So if your domain is not available with whatever you wish for, you can actually check in other top level domains like .net, .org, .ai, right? Okay. Number 2, registering the domain with required contact information. Once you have chosen an available name, register it with Route 53 by providing names and contact details for the domain's owner and other contacts. This step is crucial for the administrative and technical management of the domain. Number 3, Amazon Route 53 authoritative DNS service setup. Upon registration, Route 53 automatically sets itself as the DNS service for the domain, creating a hosted zone with the same name as your domain and assigning a set of name servers. These servers direct traffic to your resources like a web server or an S3 bucket. 4th, information sent to the registrar and registry. The registration process concludes with your information being sent to the registrar, Amazon registrar or Gandhi. There is a service called Gandhi, and then to the registry responsible for the domains TLD, .com, .net. And this for example .com, .net or whichever top level domain you have chosen. and this step formalizes your claim to the domain name. So after you pay money, registry, everything is registered, then you own the domain name, because you have the ownership. Like you provide your information, like basic information, name, email, phone number, contact, etc. Number 5, domain name information stored in public whois database. The registry stores your domain information in their database and also places some of this information in the public whois database, allowing others to see who owns the domain and how to contact them if necessary. Okay, how Amazon Route 53 routes traffic for your domain. So first, let's say a user opens a web browser and enters, for example, www.example.com in the address bar. So he has entered. Now step 2, the request for example.com is routed to a DNS resolver. So the request goes here, which is typically managed by the user's internet service provider, such as cable internet provider, a DSL broadband provider, or a corporate network. Then third, the DNS resolver for the ISP forwards the request for www.example.com to the DNS root name server. So it comes here. Fourth, the DNS resolver forwards the request for www.example.com again, this time to one of the TLD name servers for the .com domain. And the name server for .com domains respond to the request with the names of the 4 Route 53 name servers that are associated with the example.com domain. The DNS resolver caches stores the 4 Route 53 name servers, and the next time someone browses to example.com, the resolver skips to step 3 and 4 because it already has the name server for the example.com. The name servers are typically cached for 2 days. So at this point, it is already, so if it's first time in the world, this will be cached at the name server for .com. So here, and in the .com top level, there will be an entry for example. So because after example, all the .com domains will be stored in this particular name server. Then fifth, the DNS resolver chooses a Route 53 name server and forwards the request for example.com to that name server. So after this, it has come here like this, and because there is an entry for this particular name server, so Amazon Route 53 name server. And then step number 6, the Route 53 name server looks in the example.com hosted zone for the www.example.com record, gets the associated value such as the IP address for a web server, and returns the IP address to the DNS resolver. So here it goes back to the DNS resolver, this big chunk of infrastructure or a server or software. Then 7th, the DNS resolver finally has the IP address that the user needs. The resolver returns the value to the web browser. So herein it comes to the browser. And step number 8, the web browser sends a request for www.example.com to the IP address that it got from DNS resolver. This is where your content is, for example, a web server running on Amazon EC2 instance or an Amazon S3 bucket that is configured as a website content. So herein it goes like this, and finally it fetches content for this particular IP. And step number 9, the web server or other resources at 192.0.2.44 returns the web page for www.example.com to the web browser, and the web browser displays the page. So herein you get the information back to your browser. Okay. So now next is how Amazon Route 53 checks the health of your resources. So internally Amazon Route 53 has health checkers. So let's see how they work. First, creation of health checks. So you define health check parameters including endpoint IP or domain, protocol, and request interval and failure threshold. So you define all this. Second, a regular interval checking. Amazon Route 53 performs checks at specified intervals determining resource availability. Then third, failure thresholds and notifications. If the failure threshold is met, Route 53 deems the resource unhealthy and can trigger notifications. Then fourth, CloudWatch integration. Health checks can be linked with CloudWatch alarms to provide detailed notifications and metrics. Finally, fifth, routing policy adjustments. So based on health check outcomes, Route 53 modifies routing policies to direct traffic to healthy endpoints. Okay, next is domain registration concepts. So first, we have domain name, the human readable address of a website that users type in a browser to access it, like example.com. Second, domain registrar. So this is aggregated organizations responsible for registering and managing domain names for all the top level domains. So top level domains are .com, .org, .ai. I mean, the list is very huge, but I'm just giving some examples. Number 3, domain registry. Organizations that manage the registration of domain names within the domains they operate, like .com, .net. And then domain reseller, third party companies that sell domain names on behalf of registrars. Top level domain, TLD, the last segment of a domain such as .com, .org, or country specific endings like .us, .uk. So those are called as TLDs, top level domain. Okay, domain name system concepts. So we'll see some more DNS concepts. So first is alias record, a type of DNS record used to point one domain to another, primarily for AWS resources like S3 buckets or CloudFront distributions. Okay, authoritative name server, servers that have the definitive information about part of the DNS, providing responses to the DNS resolver's request. Third, CIDR block represents a range of IP addresses used for creating virtual subnets in Route 53. Fourth, DNS query, a device request for information about a domain name, usually resulting in an IP address response. Fifth, DNS resolver, a server that processes DNS queries and communicates with the authoritative name server to get the required information. Sixth, domain name system, DNS, which basically translates domain names into IP addresses, allowing devices to locate each other on the internet. Seventh, hosted zone, a container in Route 53 for records that route traffic for a domain and its subdomain. 8. IP address, a numerical label assigned to each device on a network, enabling them to communicate with each other. 9th, name servers, servers that translate domain names into IP addresses to route traffic appropriately. 10th, private DNS, a DNS service within AWS that allows routing of traffic within virtual private cloud VPCs. Recursive name server, also known as a DNS resolver. It processes the DNS query by requesting information from a sequence of name servers. Record, or also known as DNS record. So DNS record, entries within a hosted zone. It could be public hosted zone or private hosted zone that route traffic for a domain or subdomain to the appropriate location. 13th, reusable delegation set, a set of name servers that can be used by multiple hosted zones to simplify DNS management. 14th, routing policy, the method by which Route 53 determines how to respond to DNS queries based on various conditions. 15th, subdomain, a domain that is part of a larger domain. For example, let's say we have store.example.com is a subdomain of example.com. And 16th, time to live, TTL, the duration for which a DNS resolver caches the answer to a query before requesting updated information from Route 53. Okay, so this is an example of using your domain for a static website in Amazon S3 bucket. So this is like you have a browser, you register a domain such as example.com in DNS provider or registry provider. Then you configure the Amazon Route 53 to route traffic to your new website, and you just have a very static like a bucket, create a sample website and save the file in your S3 bucket. So first is register a domain, secure a domain name to establish your website's address on the internet. Second, create S3 bucket for root domain. Set up an Amazon S3 bucket which will store your website files using your domain name as the bucket name. So name has to match. Third, configure bucket for hosting. Enable the S3 bucket to host your static website, setting up properties like index document and error document. Fourth, set up redirection optional. This is an optional. If you have a subdomain, configure it to redirect request to the root domains bucket. Fifth, upload website content. Populate your S3 bucket with your website files such as HTML, CSS and image files. Then sixth, edit block public access settings. Adjust the bucket's public access settings to allow users to view your website content. 8. Test domain endpoint. After setup, use the bucket's endpoint to test that your static website is accessible. Okay, this one is already done. So 7th was attach bucket policy. So this is implement a bucket policy to grant public read access to your website files. Okay, 9th, route traffic via Route 53. Configure Amazon Route 53 to direct internet traffic to your static website's S3 bucket. And 10th, finally test your website. Open a web browser with your domain name to ensure that the website is live and functioning as expected. Okay, this is one more example using CloudFront to serve a static website. So herein we will have extra component. Before this was directly going to the bucket. Now we have CloudFront to basically make it faster, and because CloudFront is an edge location device. So let's see what are the steps. So first, register your domain name. Secure a domain like example.com to establish your web presence. So first, buy and register a domain name. Second, create a domain certificate. Certificates are essential for HTTPS. So in this case, because we are using CDN, we need to have a certificate. Third, create S3 bucket for website and subdomain. Set up one S3 bucket for hosting your site and another to handle subdomain redirect. So you can have a architecture like this, one for serving hosting your website and another for if there are any subdomain redirects, it can go to the main S3 bucket. Fourth, upload your website to the S3 bucket. So populate your S3 bucket with your website files, HTML, CSS and JS image files. Fifth, create CloudFront distributions. So set up CloudFront to deliver your content globally with low latency. So CloudFront has this feature, it can directly plug in to S3 bucket and give you another endpoint for CDN. Then sixth, configure Route 53 to route traffic. So link your domain to your CloudFront distribution using Route 53 AWS DNS service. So this has feature where it can directly plug in CloudFront distribution and let you use the domain name which you have registered as. So you will use something like example.com, but internally it will be served by the CloudFront distribution. Then last steps, verify secure website access. So test your domain in a web browser to ensure it's live and secured with HTTPS. Okay, now let's see registering a new domain in Route 53. So we are registering a new domain directly in Route 53. So first step is choose a domain name. Start by selecting a unique and memorable domain name that reflects your brand or service, and it is the first step in creating your online presence. So you have to purchase. Then next is purchase through AWS Marketplace. So use AWS Marketplace to find and purchase your chosen domain name. AWS provides a seamless integration for registration. Step 3, domain registration process. Follow the guided process to register your domain. This involves entering your contact information and agreeing to the terms of service. Set up DNS settings. Configure your domain's DNS settings to point to your hosted resources. Route 53 provides a robust DNS service to manage your domain's traffic efficiently. Fifth, configure privacy protection. Opt for privacy protection to hide your personal information from WHOIS database, enhancing your online security. So this option is also there. So because WHOIS database, people can see information. So there are some options which all information you want to make it public or private. Sixth, verify domain ownership. So you will need to verify your domain ownership through email confirmation as part of the registration process. And Seventh, manage domain billing. So set up and manage your domain's billing preferences within AWS and keep track of your domain registration and renewal fees to maintain your online presence. Okay, now if you want to transfer domain registration to Route 53 from some other domain service provider, so first confirm TLD support by Route 53. So first verify that Amazon Route 53 support the top level domain of the domain you wish to transfer. So in some cases the TLD, for example .com, it's not .com, it's like .something, may not be supported by Route 53. Second, optional transfer DNS service. So consider transferring your DNS service to Amazon Route 53 or another provider before starting the domain transfer process. Third, change current registrar settings. So adjust the settings with your current registrar, typically including unlocking the domain and obtaining the transfer authorization code. So basically you have another domain up and running, you are transferring the whole domain to Route 53 as a DNS provider. So fourth, get name server names. Secure the names of your name servers from Amazon Route 53, which you will need to update your domain configuration. Fifth, request the transfer. Initiate the domain transfer request through Amazon Route 53 console, providing necessary details like the authorization code. Sixth, this is only for India, AISPL only, pay fee. So customers in India must pay the transfer fees as part of Amazon Seller Services Private Limited requirements. Seventh, click confirmation and authorization links. Verify the transfer by clicking on the links in the confirmation and authorization emails sent by Amazon Route 53. Then number 8, update domain configuration. After the transfer, update your domain's configuration as necessary to complete the setup within Route 53. Okay, making Route 53 the DNS service for an active domain. So first, get current DNS configuration. So this is essential for mirroring your setup in Route 53. Collect info from your existing DNS provider. Second, you have to create a hosted zone. This is your domain's home in Route 53, allowing you to manage DNS records. So hosted zone is like a home, the first home that you create when you transfer or you make a DNS service Route 53 as the active domain. So third step in that is create records. Replicate your DNS settings by creating necessary records within your hosted zone. So now, because first you create a hosted zone, then you have to create records. Then lower TTL settings, so you can reduce the cache time. So this will make the transition to Route 53 quickly, because they will propagate. It will expire and it will propagate faster. So all the DNS resolver will have the newest setting of Route 53 name servers. So step 5, remove DS record. So if DNSSEC configured, so this is important for preventing validation issues during the transfer process. Sixth, wait for old TTL to expire. Ensures that DNS resolvers request the most current DNS information. Seventh, update NS records to Route 53 servers. Redirects DNS queries to your new Route 53 setup. Then 8, monitor traffic. So keep an eye on your domain's traffic to ensure everything is functioning correctly post migration. 9th, increase TTL for NS record. So once you are confident in the stability of your new DNS setup, revert TTL to a standard value for efficiency. 10th, transfer domain registration to Route 53. So this is optional, but you can consolidate your domain management within AWS, like whole complete thing in AWS, and re-enable DNSSEC if required. So if you had DNSSEC enabled, reconfigure it to maintain security standards. Okay, making Route 53 the DNS service for an inactive domain. So this domain is not up and running, for example, but you have purchased the domain, but it's not serving any traffic. So step 1, obtain current DNS configuration. So gather DNS setup details from your existing DNS provider. to ensure a smooth transition to Route 53. Second, create a hosted zone for inactive domains. So establish a new zone in Route 53, marking the domain's new administrative space within AWS. Third, create DNS records for domain setup. Replicate your previous DNS configuration in Route 53 by creating corresponding records within the hosted zone. Fourth, update your domain registration to Route 53 servers. So finalize the DNS service migration by pointing your domain registration to Route 53 name servers, which will complete the transition. Okay, configuring DNS routing for a new domain with Route 53. So first, Route 53 automatically becomes DNS service upon domain registration. So when a domain is registered with Route 53, it is set as a DNS service for the domain by default. Hosted zone creation with domain name. Route 53 creates a hosted zone that matches the domain name, serving as a home for DNS configurations. Third, assign 4 name servers to the hosted zone. These name servers are essential for DNS resolution, allowing the internet to find your domain. Fourth, updates domain to use Route 53 name servers. So this update ensures that all DNS queries for your domain are routed through Route 53 servers. Fifth, create records for traffic routing. So records within the hosted zone define how internet traffic should be directed. For example, routing domain requests specific to specific servers or services. So example, routing to an EC2 instance via Elastic IP. So an example setup could involve routing traffic for a domain to a web server or an EC2 instance, specifying the instance Elastic IP in the domain's DNS record. So this is a very simple example. Let's say you have just purchased a new domain from AWS and you are setting it in Route 53. So you have a single EC2 instance for simplification, and you have that's running traffic, it's serving traffic. And what you do is just create a public hosted zone, create a record, and that record, well, let's say www.example.com, and you point it to the IP, Elastic IP of your EC2, and from there onwards you can serve your traffic, the DNS globally through the Route 53. So this is the whole setup is in Route 53. You bought the domain from the Route 53 and you are configuring the new domain. Okay, next is, I have talked about public hosted zone and private hosted zone. Let's see what is the difference. So first, a public hosted zone in Amazon Route 53 is a container that holds information about how you want to route traffic on the internet for a specific domain such as example.com. So just remember, public means it's like publicly available, so anybody in the world can access it. It's not for virtual private cloud or private cloud or anything like that. So that's why this is like across the globe. So public hosted zone, so it's publicly available. Second, DNS management for domains. It allows for efficient management of DNS records for your domains, enabling you to control how the global internet traffic is directed to your resources. Third, easy to manage and scale. Amazon Route 53 provides a user-friendly platform that makes it simple to manage DNS setting and scale also as your traffic grows. Fourth, integration with AWS services. Public hosted zones are deeply integrated with other AWS services and providing seamless connectivity. Fifth, traffic flow and health checks. So features like traffic flow policies and health checks enable intelligent routing and ensure high availability and performance of your applications. Next, let's see what is private hosted zone. First, creation and association. A private hosted zone in Amazon Route 53 is designed for managing DNS records within one or more Amazon VPCs, virtual private cloud. So private cloud and private hosted zone. So both are linked together. This allows for internal network use. So it can be within your VPC or corporate data center direct connect, but it's private. It's not for public consumption. It can be associated with a VPC upon creation, with options to associate additional VPCs later. DNS query handling. Route 53 responds to domain queries from application within a VPC based on the DNS records in the private hosted zone, ensuring that internal traffic remains isolated and secure. Third, supported routing policies. Various routing policies such as simple, failover, multi-value, answer weighted latency based and geolocation are supported for private hosted zone as well. We'll see the routing policies in later slides. Split view DNS benefits. So it enables split view DNS configuration, allowing the same domain name to serve different content or services internally within VPCs, optimizing internal traffic management and security. So split view is something like you have example.com, but depending on where the user is coming from, whether public or through your corporate data center or from VPCs, you serve them different content based on their source location. So fifth, traffic routing provides precise control over traffic routing for your domain and subdomains within VPCs, and this is useful for directing traffic to specific internal resources like database servers or application, enhancing performance and security. Okay, working with records in Amazon Route 53. So we'll see all the DNS records. So it's applicable for both public as well as private hosted zone. So after creating a hosted zone for your domain, it's crucial to set up records that dictate how DNS traffic should be routed for that domain. And this is a mandatory or foundational step. So you must create some records to basically start serving your traffic. Second, routing internet traffic. So you can configure records to direct internet traffic for your domain to the IP address of a host within your data center. Also, so this option is also the elastic IP, which I talked about. Or there are some more options as well, like load balancer and all. Third, email routing with MX records. So by using MX records, you specify how email for your domain should be routed. For example, sending emails addressed to, for example, ichiro@example.com to designated mail server. So depending on the domain, you can designate some mail server to handle the mail part of it, not the website, the HTTP part of it. So this is a slightly different protocol, SMTP protocol and all. So fourth, subdomain traffic routing. It's possible to direct traffic for subdomains. For example, you have subdomains store.example.com or something to different hosts' IP addresses. So all subdomains of example.com, you can have different IP address or different target or destination. This allows for more granular control over how different sections of your domain are accessed. Fifth, record types and information. Each record encompasses the domain or subdomain name, a specific record type, for example MX for email routing, and additional detail pertinent to record type like mail server host names and priorities for MX records. So we'll see all the record types later in the slides. Sixth, hosted zone record limitations. The records within a hosted zone must conclude with the hosted zone's name. For instance, the example.com hosted zone may include records for its subdomains like www.example.com, but not for domains outside its scope. For example, www.example.ca. So if the hosted zone is example.com, it can only have subdomain or top level domain example.com, store.example.com, or sell.example, shop.example.com or something. But the top part cannot change. You cannot have example.ca or example.uk or example.org, something like that. Okay, next, routing policies in Amazon Route 53. So we have couple of routing policies. So first is simple routing policy. So I will be going through all of it one by one. So this is for single resource traffic and straightforward setups. So this is a default policy. It just round robins. Failover routing policy. This is active passive failover. Third is geolocation routing policy, and it's routes by requester location, and you can localize content and reduce latency. So US, Europe, for example, you can have geolocation. So if customer is coming from Europe, they will be served in server from Europe, and you can configure based on globally, like it's not only that region or continent. Geo proximity routing policy, and this one, traffic is directed based on the geographic location of your resources and users, with optional bias parameters to adjust traffic flow between locations. So this is a bit advanced. There is a bias parameters. So depending on bias, you can configure where. So you can provide a weight. For example, somebody in Africa want to get traffic served from either US or Europe, but you can adjust like where it should go. Fifth, latency routing policy. This optimizes for lowest latency by routing users to the AWS region that whichever offers the best response time. So it will check what is the speed, whichever have least speed, it will serve traffic. Then you have IP based routing policy. It routes by IP address. Seventh, multi-value answer routing policy. So this is just random. So Route 53 responds with up to 8 healthy records selected at random, and you can balance load across multiple resources. So it's a random selection. Number 8, weighted routing policy. Traffic is distributed across multiple resources based on the weights assigned, allowing for experimentation and phased rollout. So you can assign some weight to the destination or the targets, and based on the weight the traffic will be served more or less. So some will have more. For example, if it's 100%, you can say 80% to this destination EC2 1 or 20% to EC2 second. So whichever have more weight will serve more traffic. Okay, now we'll see all the routing policy in detail. So first is simple routing policy. Standard DNS records configuration. Simple routing enables the configuration of standard DNS records without the complexity of Route 53's specialized routing options like weighted or latency based routing. Second, single resources traffic routing, typically used to route all traffic to a single resource, such as web server hosting a website. Simple routing supports straightforward DNS setup. Third, private hosted zone application. This policy can be applied to records within a private hosted zone, which helps in internal network traffic management and working with VPC. Fourth, multiple values in a single record. While multiple records with the same name and type are not allowed, a single record can contain multiple values like IP addresses, enabling a form of load distribution. Fifth, values returned in random order. When multiple values are specified in a record, Route 53 returns these values in a random order to the resolver, which then selects one to use for the DNS query. Next is failover routing in Amazon Route 53. Primary and secondary routing. Failover routing policy allows traffic routing to a primary resource when it's healthy and to a secondary resource when the primary is unhealthy. This can include directing traffic from a web server to an Amazon S3 bucket configured as website during downtimes. So primary can be your actual EC2 instances, and secondary could be a static website. If your servers go down, it can always serve traffic from a static website, though it may not be exactly operational exactly like all the functionality, but it can still provide some limited functionality. Second, health checks integration. Integrates with Amazon Route 53 health checks to monitor the health of resources. Route 53 automatically switches traffic between primary and secondary resources based on health status. Third, application in private hosted zones. Failover routing can be used within private hosted zones, which helps in internal network management and ensuring high availability for internal applications. Fourth, multiple values handling. Although primarily is used for active passive setups, the policy supports specifying multi-IP addresses or resources in records, enhancing DNS response flexibility. Fifth, alias records for failover. Enables the creation of failover alias records, directing DNS queries to different AWS resources based on their health status, such as ELB load balancer or S3 buckets. Third is geolocation routing in Amazon Route 53. First, customizes resources delivery by user location. Geolocation routing enables the selection of resources based on the geographic origin of DNS queries, allowing for targeted content delivery. Second, directs in traffic to optimal endpoints. For example, requests from Europe could be directed to a load balancer in Frankfurt, optimizing response times and resource utilization. Third, content localization and distribution control. This feature can localize content to match user language preferences or restrict content distribution within specific geographical rights. Fourth, load balancing across endpoints facilitates a consistent and manageable approach to distribute traffic across multiple endpoints, ensuring high availability and performance. Next is geo-proximity routing. First, routes traffic based on user and resource location. Amazon Route 53 uses geo-proximity routing to direct traffic to the nearest available resource, optimizing for reduced latency. Offers bias to adjust traffic routing area. A unique feature, bias allows for fine-tuning of the geographic region from which traffic is directed to a resource, either increasing or reducing the area. Supports AWS and non-AWS resources. Geo-proximity routing can be applied to resources within AWS, specifying AWS regions or local zones, and to non-AWS resources by providing latitude and longitude. Fourth, bias manipulation to expand or shrink geographic regions. Adjusting the bias positive, if you make it positive to expand and negative to shrink, dynamically changes the geographic area affecting net traffic routing, enabling precise control over traffic distribution based on geographic proximity. Fifth, latency-based routing in Amazon Route 53. Optimized global traffic flow. Latency-based routing directs user requests to the AWS region that offers the lowest latency, ensuring fast response times by serving requests from the nearest geographical location. 2. Dynamic response to network conditions. Latency measurements are continually updated, reflecting changes in network connectivity and routing. This adaptability ensures that the routing decisions are based on the most current data, optimizing performance over time. Worldwide resource utilization. By setting up latency records in multiple AWS regions, businesses can make use of global resources effectively, ensuring users are served from the optimal location regardless of where they are in the world. Fourth, enhanced user experience. Users experience improved load times and smoother interactions with the applications as latency-based routing minimizes delay by intelligently routing traffic based on geographic latency measurements. Fifth, seamless integration with health checks. Latency-based routing can be combined with Amazon Route 53 health checks to ensure traffic is only routed to healthy endpoints. If the primary region becomes unhealthy, Route 53 automatically reroutes traffic to the next best region, maintaining availability and performance. Sixth, IP-based routing policy in Route 53. First, fine-tune DNS routing based on network understanding. IP-based routing in Amazon Route 53 allows for detailed DNS routing configuration, leveraging knowledge of network applications and client behaviors to direct end users efficiently, optimize performance or reduce network cost. This routing policy enables the customization of DNS routing to enhance user experience by optimizing performance or to achieve cost savings by reducing network cost. Third, utilize user IP to endpoint mappings for precise control. By uploading user IP to endpoint mappings to Route 53, administrators gain granular control over the routing process, allowing for highly specific routing decisions that cater to unique requirements of their network and users. Okay, multi-value answer routing. First, one offers multiple DNS responses, enables configuring Route 53 to return several values such as IP addresses in response to DNS queries, allowing for improved availability and load distribution. Supports health checks for resources, incorporates health checks to ensure only healthy resources IP addresses are returned, enhancing reliability and uptime. Not a load balancer alternative. While it provides multiple DNS responses, it is intended for complement rather than replace load balancing solutions, offering a simpler method to distribute traffic across multiple resources. Fourth, suitable for AWS and non-AWS resources, compatible with both AWS resources by specifying AWS regions or local zones and non-AWS regions resources using latitude and longitude for geolocation. Fifth, can respond with up to 8 healthy records for any DNS queries. Route 53 can reply with up to 8 healthy records, providing different answers to different DNS resolvers, thus enhancing the distribution of traffic across multiple servers. Weighted routing in Amazon Route 53. Associate multiple resources with a single domain. Use weighted routing to link multiple servers or endpoints to a single domain. For example, example.com or subdomain store.example.com. Second, customize traffic distribution per resource. So allocate traffic proportions to each resource by assigning a weight, offering granular control over how much traffic each resource receives. Ideal for load balancing and software testing. Weighted routing facilitates efficient load distribution across resources and allows for the testing of new software versions under controlled traffic conditions. Fourth, assign relative weights to control traffic. So by assigning weights, for example, 1 for minimal traffic and 255, so these are the values, 1 for minimal traffic and 255 for maximum. Route 53 distributes traffic proportionally, enabling precise management of server loads. Fifth, dynamically adjusting traffic balance by modifying weights. Alter weights to shift traffic between resources easily. Setting a resource weight to 0 stops traffic flow rate, which provides flexibility in traffic management. Okay, choosing, so this is one important feature. There's a alias and non-alias records. So in Amazon Route 53 offers a feature called alias records. So choosing between them, alias and non-alias. So alias records, Route 53 extension for DNS. So this is something which Route 53 has an extension on top of DNS system. Alias records in Amazon Route 53 extend DNS functionality, allowing routing to DNS resources and other Route 53 records. Second, zone apex alias. This is an exclusive feature. Alias records can point to the zone apex, which is, for example, let's say in example.com. It's the whole only example.com without dot or www, something like that. And unlike CNAMEs, offering a solution for root domain DNS queries. A third, dynamic DNS query response. Route 53 dynamically responds to DNS queries for an alias record with applicable values, supporting various AWS services like load balancer and Kubernetes and all. Fourth, alias versus CNAME. So the key difference, alias records can route queries to specific AWS resources and support zone apex pointing. So as a AWS resources like load balancer or some other endpoints, for example DynamoDB endpoint or Kubernetes or Fargate endpoint, which CNAMEs cannot. So CNAMEs cannot provide this functionality. Additionally, alias records are not charged for DNS queries to AWS resources, and this is totally free. So if you configure an alias record to point to a backend load balancer, you are not charged. Pricing, alias versus CNAME. Route 53 does not charge for DNS queries resolved by alias records to AWS resources, whereas CNAME queries are charged. So you will pay if you have CNAME records. Okay, let's see all the supported DNS record types. So we are covering the DNS record types. So first is A record type. This maps domain names to IPv4 addresses and directing traffic to a specific server. AA record type, similar to A records but maps domain names to IPv6 addresses for traffic direction. Then we have CAA record type, specifies which certificate authorities CAs are allowed to issue certificates for a domain, which enhances security. Then we have CNAME record type, redirects one domain name to another domain name, and this excluding the zone apex. Fifth one, DS record type, used in DNSSEC to connect a child zones DNS key to parent zone, ensuring secure delegation. Sixth, MX record type directs email to mail server based on priority and to facilitate email delivery. Seventh, NAPTR record types enables the use of regular expression based rewriting rules to dynamically map domain names to URLs or other domain names. Then NS record type, and this lists the authoritative name servers for a domain, and this is used for DNS lookup process. Then you have PTR record types, maps an IP address to canonical hostname, CNAME, not CNAME, maps an IP address to canonical hostname, primarily used in reverse DNS lookups. 10th, SOA record type provides information about a domain and its associated zone, including the primary name server and email of the domain administrator. 11th, SPF record type. This is an outdated record type for listing authorized mail servers. Use TXT records for SPF instead now. 12th, SRV record type specifies a port for specific services, facilitating the use of services like VoIP, VoIP, instant messaging and email. And last, TXT record type this one stores text information in DNS, commonly used for verifying domain ownership and implementing email security measures such as SPF and DKIM. And that's all. Thanks for watching.